Hello, hi everyone. Welcome to the Student the Brand. This is your Siva sir. Today we are going to discuss electricity, CBSE Grade-10 physics. Electricity, CBSE Grade-10 physics. So in this topic, we'll discuss all the points like definition of electric current, conventional current, electric current, electric circuit, electrical components. We'll discuss this topic. Okay, so you can check. If you have any doubts, you can ask. So we'll discuss more. Still, if any concerns related to any doubts, if you have, you can ask. Okay, we'll work out on it. Okay, so mainly focus on we are focusing on preparation. Notes I'll try to give. So if it is possible, you can write the notes also. Try to write running notes. So it will be helpful. Right? I hope it is clear now. Now it is clear. Chalo. Electric current. Rate of flow of charge. Rate of flow of charge. I equal to Q by T. So we are discussing electric current definition. And here generally summarizing the points, and along with that practicing problems also, summarizing the concept, overall concept I'll explain. Along with that, so problems I'll plan. So we'll plan electricity problems. So we'll work out on electricity problems too. So problems also very important. Mainly we need to focus on it. Okay. So I hope now it will be fully clear. Okay. So student the brand. Welcome to Student the Brand channel. Hope so. It is clear to you all. So first point is electric current. I equal to Q by T. So here, I equal to Q by T is we are discussing, right? I equal to Q by T. So I is the current. The rate of flow of charge. Is called current. Rate of flow of charge is called current. I equal to Q by T. So SI unit of charge is Coulomb. SI unit of time is second. And SI unit of current is ampere. So SI unit is ampere. So we can see I'm taking this one. I'm considering this one now. Okay, so I'll write here better, so it will be visible, right? I equal to Q by T. So I is nothing but current. I is nothing but current. So charge is Q is the charge. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. And SI unit of current is ampere. SI unit of current is ampere. SI unit of current is ampere. Once again, SI unit of current is ampere. 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 So I equal to Q by T. I equal to Q by T. I am saying now. What is SI unit of current? Ampere. SI unit of charge? Coulomb. SI unit of time? Second. Once again, SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere. So we can represent 1 ampere equal to 1 coulomb per 1 second. So very important for one more question. So one more question. So keep in mind this one, this point. I equal to Q by T. SI unit of charge is coulomb. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. And SI unit of time. SI unit of time is second. SI unit of time is second. Now we are going to the next one. 1 ampere equal to, so how can we define 1 ampere? 1 ampere is equal to 1 coulomb of charge flowing through unit cross section area. So I am taking this area of the cross section. So this area of the cross section I am taking. Area of the cross section I am considering. So this is the area of the cross section of this. Okay. So this, if you are taking the wire, so current will pass inside like this. Okay. So this one like this only. So this is called area of the cross section. This is called area of the cross section. So I equal to Q by T. The rate of flow of charge is called electric current. So 1 ampere equal to 1 coulomb per second. 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 So that is nothing but the rate of flow of charge. Rate of flow of charge is called electric current. Or one more definition, the flow of charge through unit cross section area per second. The flow of charge through unit cross section area per second. The flow of charge through unit cross section area per second. The flow of charge through unit cross section area per second. So this is a unit cross section area. So anything we are discussing with the unit cross section. So we are considering 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So 1 ampere equal to 1 coulomb per 1 second we are taking. So 1 coulomb of charge flowing through unit cross section area per second. So what is 1 ampere? 1 ampere is equal to 1 coulomb of charge flowing through unit cross section area per second. So if you ask current, so current you can come. So I have to learn. If you call like that, will it come? You have to learn. Okay. So I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So like that, you have to remember the points. So what is the SI unit of current? Ampere. What is the SI unit of charge? Coulomb. What is the SI unit of time? Second. So 1 ampere is what? Define 1 ampere. Define 1 ampere. So they will ask about in this session, in this concept, they will ask about define 1 ampere. Define 1 ampere. 1 ampere. So this is one question. Second question is, so SI unit. So there is a possibility ask SI unit. What is the SI unit? Okay, SI unit related to this one. SI unit they will ask. And the third point is related to charge. So related to charge we'll discuss. What exactly the charge? Charge is a property of the matter. There are two types of charges are there. Charge is a property of the matter There are two types of charges are there: positive charge and negative charge. Positive charge and negative charge. Positive charge and negative charge. So now we will discuss about positive charge and negative charge. Will it attract or repel? How it will be based on the sign. Based on the sign. So it depends. So now you can see. Now you can see. I am considering positive charge, negative charge, right? Positive charge and negative charge. So now you can say there are two types of charge. Is a property of the matter. Charge is nothing but property of the matter. So what is charge? Charge is a property of the matter which influence the presence of other charges. Which influence the presence of other charges. If charge is there here, if it is charge is there, either positive or negative. So around it, if around it any charges are there, so those no, so those charges are influenced by this charge. Those charges are influenced by this charge. So around it will be there are positive charge, negative charge. There are two types of charges are there: positive charge and negative charge. One is positive charge and negative charge. Negative charge. There are two types. So positive charge and negative charge. So positive charge will attract. Positive charge and positive charge will attract, and whereas negative charge and negative charge will repel. Okay, so positive charge will attract, negative charge and negative charge will repel. So like that we can take. So those are the types of charges, how it will attract, how it will repel. So it depends, right? Next one, so we are going to the proper. See, if the charge is moving inside of the conductor, will it move only one or two charges? Will only one charges, two matches will move. So if you are taking this a conductor, only one charge, two charge will move? No. So there are many charges will move inside of the conductor. There are many charges will move inside of the conductor. Many charges. So I'm considering here charges will move. So like a positive charge, negative charge, positive charge, negative, positive, negative, positive, negative, positive, negative, negative, positive, positive, negative, negative, positive, negative, negative, positive, positive, negative, negative, positive, negative, positive, 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 negative, negative, positive, positive, negative, negative, positive, 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 negative, positive, negative, positive, negative, positive, negative, positive, negative, negative, positive. So the charges will move inside of the conductor like a bunch, like an integral multiple. There are number of charges will move inside of the conductor, right here, inside of the current carrying conductor. So quantization of charge is integral multiple of L. So charge is integral multiple. So either you take positive or you can take negative. So Q equal to Ne. N is the integral multiple. So normally you don't take the formula I equal to Q by T. 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 Yes. So we can see I equal to Ne by T. Ne by T. I equal to Ne by T. Ne by T. Ne by T. I equal to Ne by T. Ne by T. Ne by T. Very, 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 very good. Nice. Excellent. Marvelous. Mind blowing. So here you can see I equal to Ne by T. Now we know charge. The charge on electron is So the charge on electron is on one electron, how much charge is present? On one electron, how much charge is present? So on one electron, you can see there are you can see on one electron how much charge is present. These values are very important. So I'll explain, I'll write. So make it one electron, on one electron 1.6 into 10 power minus 19 coulomb. So very, very important, very, very important formula. So make a note of it. So very, very important formula. You have to remember this value. One mark question will come. Okay. So in MCQs also this question will come. Even problems also they won't give. In problems they won't give this value. We have to remember this value. In problems they won't give this value. You have to remember this value. Clear? Yes. Now on one electron, in 1 coulomb, how many electrons are present in 1 coulomb? So 1 equal to, so 1 electron we can say on 1 electron. So 1 E equal to E bar equal to 1.6 into 10 power minus 19 coulomb. In 1 coulomb equal to 1 by 1.6 into 10 power minus 19 minus 19. So 1 by 1.6 into 10 by 10 into 10 by 10 into 10 power 19, 10 power 19. So if you are solving 10 by 1.6, so sorry, one, how we will get 16 only will get, because we are multiplying, right? So if you are getting 16, then 10 power 19. So if you do this value, 10 by 16, you will get 0.625 into 10 power 19. So if you are taking in 1 coulomb, so in 1 coulomb 6.25 into 10 power 18 electrons. So this is the number. So this many electrons are present in 1 coulomb. So very important. So make a note of it. So this concept is very important. Even in board exam, they will ask for 1 mark question. 1 mark question, this concept. So try to practice, try to remember, try to recall. So write in one place. So write in one place. Okay. So this also they will ask for 1 mark. They will ask for 1 mark. 1 mark question. 1 mark question. 1 mark question. So this is 1 mark question. This is 1 mark question. And the process, they may ask for 2 marks also. Process means this problem they will ask for 2 marks. 2 marks question they will ask, right? So make a note of it. 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 Very important. And next one, we are going to the electrical appliance. I will explain. So electrical appliance, after that electric circuit is there. So before knowing electric circuit, actually it is a electric current. Electric current, no, current will passes in his conductor only, right? So electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is known as electric circuit. A continuous and closed path of an electric current is known as electric circuit. So in electric current, there are 2 types of current. So like 2 types of current. So based on the direction, based on the electrons, protons, sir. Why, sir, you are saying only one current is there? So that is electric current only. No, how you are saying 2 current? Based on the direction, positive charges, negative charges, accordingly. So we are discussing. Now I am explaining about electrical components. So I am taking this cell. First one is cell, and the second one is battery. So So I'm taking battery like this. Here I'm considering the battery, positive term, negative term, battery. And next one we are going with that battery. Third one we are going to switch. So switch I'm considering this is actually, if dot is not there, that is open switch. If dot is not there, that is open switch. Open switch. And third, fourth one is closed switch. Closed switch means we are taking like this. So closed switch. Okay. And fifth one is resistor. This is the resistor. The device which is used to oppose the electric current in the circuit, that is a resistor. Next one we are going to the ammeter. So sixth one is ammeter. Ammeter is a device which measures electric current. And voltmeter is a device which measures the potential difference. And like a rheostat, next one we are taking the rheostat. So rheostat I'm considering either this one or one more also we are considering like this. Okay, so I'm considering here. These all points are helpful for not only grade 10 physics, it is also helpful for JE, NEET and MCET students, okay, and grade 12 students also, because electrical charges and fields, so these are for, so topics will be available, the topics will be helpful for the students, okay. Then next one, we are going to the wire joining and wire crossing. This is the wire joining and wire crossing. So wire crossing like this. in middle it will be crossing, that's a crossing symbol. Wire joining and wire crossing. So cell, battery, open switch, close switch, resistor, ammeter, voltmeter, rheostat, and wire joining and wire crossing, wire joining and wire crossing. So this is about electrical appliance, electrical appliance. So now I will explain, now I will explain about 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 electrical circuit, electrical circuit, electrical circuit, electrical circuit. So I'm taking, this is the battery, 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 battery. This is the closed switch. So ammeter I am connecting here. I am considering bulb symbol, bulb symbol. This is the bulb. So bulb symbol is here. Bulb, 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 bulb. And here I am connecting to the switch. Now current is passing, positive, negative. Current is passing, positive, negative. Generally, so electrical. So first one is conventional current. Conventional current. And the second point is electric current. So what is the meaning of conventional current and electric current? Conventional current and electric current. Conventional current is nothing but so before finding electron, proton, neutron, before finding the electron, proton, neutron, so the scientists were given the statement, the positive charges direction, the flow of the current direction is the flow of charges, the flow of positive charges. So the direction of the current will be taken from positive terminal to negative terminal. After finding the movement of the electrons, because of the movement of electrons, current will pass in the conductor. Because of the movement of the electrons, current will pass. That's why, so we no need to change that one. We no need to change entire all the theorems, entire statement. So we just use that current as a conventional current. The flow of positive charges will be considered as a conventional current. And coming to the electric current is nothing but the flow of electrons. Electrons will move from negative terminal to positive terminal. Electrons will move from negative terminal to positive terminal. So here electrons will move from negative terminal to positive terminal. Conventional current move from positive terminal to negative terminal. Here is a conventional current. Flow of positive charges. Positive charges will move from positive terminal to negative terminal. Electric current. So electrons will move from negative terminal to positive terminal. Conventional current. So by the flow of charges, positive charges, electric current. So flow of electrons. So these are the difference between conventional current and electric current. Conventional current, electric current, conventional current, electric current, conventional current. And here electric circuit. So we'll discuss about electric circuit. A closed and continuous path of an electric current. A closed and continuous path of an electric current is called a closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current is known as electric circuit. 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 A closed and continuous path of an electric current. Closed and continuous path of an electric current is known as electric current. Is known as electric circuit, not electric current. Electric circuit. A closed and continuous path of an electric current is known as electric circuit. What is that? Electric circuit. Electric circuit. electric circuit, electric circuit. So electric circuit one time, electric circuit two times, electric circuit third time. So I called electric circuit came. What is electric circuit? The closed and continuous path of an electric current is known as electric circuit. So electric circuit is telling to us. So my definition is a closed and continuous path of an electric current is called electric circuit. In the circuit, battery will be, switch will be, bulb is there, ammeter is there, rheostat can be connected, voltmeter can be connected. Yes, so these are the points. Okay, so this can be connected. So ammeter will be connected in electric circuit in series combination. Voltmeter is connected in electric circuit in parallel combination. In parallel combination. In parallel combination. Okay. So next one, electrical potential. Now we are going to discuss. So it's very emergency, very extraordinary concept. So extraordinary concept. Electrical potential difference. Are you understanding or what? Electrical potential difference we are discussing. Potential difference. Potential difference. Not potential difference. Potential difference. Not potential difference. Potential difference. Okay. So now I am considering here potential difference. What is the potential difference? What is the potential difference? Potential difference. So potential difference. Potential. 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 So potential. Yes. So potential difference is nothing but, so here is the conductor, here is the conductor, here is the conductor. So I am taking, this is one point and this one is one point. So point A, point B, within the conductor, within the conductor, within the conductor. So work, positive charge, with the positive charge is coming, we are doing some work, we are doing some work. So by doing some work to bring positive charge from point A to point B, so double equal to, oh my god, yes, so V equal to W by Q only, right? V equal to W by Q. Yes, of course. So V equal to W by Q. The potential difference, 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 the potential difference is equal to work done to bring unit positive charge from point A to point B, from point A to point B, that is V equal to W by Q, V equal to W by Q. SI unit of potential is volt, SI unit of potential is volt, SI unit of work is joule, SI unit of work is joule, SI unit of charge is coulomb. So here you can see I am taking 1 volt, 1 joule and 1 coulomb. 1 volt. Normally, if you are taking SI unit of potential difference is volt, SI unit of work is joule, SI unit of charge is coulomb. SI unit of charge is coulomb. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. 1 volt equal to 1 coulomb of charge. So 1 coulomb of charge, 1 joule is 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge. 1 volt equal to 1 coulomb, 1 joule of work. 1 volt equal to 1 volt, 1 volt, 1 volt, 1 volt, 1 volt. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point, from one point to another point. 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. Is called potential difference. Is called potential difference. Is called potential difference. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 volt equal to 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point. That is nothing but 1 volt equal to 1 joule by 1 coulomb. 1 coulomb. Whereas potential difference, potential difference, potential difference, potential difference. No. Electrical potential. Potential difference is already very discussed. Electrical potential. Electrical difference. Electrical difference. Electrical difference. Electrical difference. Electrical difference is when we are doing work. When we are doing work to bring the positive charge from infinity to the required field. From infinity to the required field. Work done to bring unit positive charge from infinity to the required field is called electrical potential. Electrical potential. So I am considering here positive charge is at infinity. Positive charge is at infinity. Here is the required field. Here is the required field. We are doing some work. We are doing some work. Potential difference equal to V equal to W by Q. V equal to W by Q. Same formula we are using. Same work is we are doing, and work done to bring unit positive charge from one point to another point is called electrical potential difference. Electrical potential means work done to bring unit positive charge from infinity to the required field. Required field. This is called required field. So if you like this video, please do like, share and subscribe. You can so required field. So if you are new to the channel, please do like and share and subscribe. So ask your friends to join to the class. If you have any doubts in this concept, you can ask me. So this is Shiva sir, the student brand. So we are discussing physics. Okay. Now that is about electrical potential and potential difference. Electrical potential and potential difference. I hope it is completed. Next, we are going to discuss about resistors are in series. Resistors are in parallel. Resistors are in series. Resistors are in parallel. So what is resistors are in series? Resistors are in parallel. So when resistors are connected in series combination, when resistors are connected in series combination, before that one more point is there, very important, very important concept, that is Ohm's law. Ohm's law, 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 Ohm's law. So Ohm's law is the here I'm taking this resistor switch, Oh, ammeter. Battery, 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 battery. Here battery. Here battery. So here is battery. So I'm taking cell. So I'm considering is Q, and here resistor, resistor, resistor. Around the resistor, there is a potential difference. There is a potential difference. Around the resistor, there is a potential difference. Positive, negative, positive, negative. I am considering here, I am considering here, I am considering here. Considering, 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 considering. Here I am considering, here I am considering, here I am considering. What is this law? Ohm's law. What is this law? Ohm's law, Ohm's law, Ohm's law. So I am taking here positive, negative. If you are taking, if you are considering, if you are considering, current is flowing in the circuit, current is flowing in the circuit, current is flowing in the circuit, current where it is flowing in the circuit, where current is flowing in the circuit, where current is flowing in the circuit, current is flowing in the circuit, right? Yes. So the potential difference is directly proportional. The potential difference across resistor, the potential difference across resistor is directly proportional to current flowing through it. The potential difference is directly proportional to current flowing through it. V is directly proportional to I, so V equal to IR. It gives the relation of it gives the definition of resistance. 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 So V equal to IR. V equal to IR. I equal to, so I am considering here, considering V equal to IR. V equal to IR. V equal to IR. V equal to IR. So V is directly V equal to IR directly proportional to I. V is directly proportional to I. Okay, so this is about definition and circuit diagram. This is a circuit diagram. Circuit diagram. So diagrammatic representation and diagrammatic representation and logical connection of electrical appliances. Electrical circuit diagram. A diagrammatic representation of logical connection of electrical appliance is called circuit diagram. Is called circuit diagram. Is called circuit diagram. Is called circuit diagram. Circuit diagram. Circuit diagram. Circuit diagram. Circuit diagram. Next one, materials required. Materials required. Materials required. What are the materials required? Materials required. 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 Materials. Materials required. Materials required. Materials required. Materials required. Materials required. Materials required. And four cells, 1.5 volt each. Four cells, 1.5 volts each. Four cells, 1.5 volts each. Correct? Yes or no? And second one I'm taking. Second one I'm considering. Resistor. That is nothing but nichrowire. Nichrowire is an alloy of. Nichrowire is an alloy of nickel, chromium, manganese and iron metals. Nichrowire is an आप सिंगर होता ना. maybe sometimes it happens because I'm a teacher. 4 cells, 1.5 volts each. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Iron metals. So, third one I am considering in the requirement of materials. So 4 cells completed, nichrome wire is completed. Next one I am considering the switch. The switch. Here is the switch. There are two types of switches. Open switch, closed switch. Open switch and closed switch. Open switch. So if you are taking the dot inside of it, then it is closed switch. If dot is not there, closed switch. Sorry, if dot is not there, open switch. If dot is there, closed switch. This is closed switch. Dot is there. What is this one? If dot is there, closed switch. If dot is not there, open switch. If you connect this switch to the circuit, that is called open circuit. If you connect closed switch to the circuit, that is called closed switch. Closed switch. Closed switch. Yes. Now we are going to the next one. We are going to the next one. What are those? So a meter, a meter, a meter, a meter. Next one is voltmeter. Voltmeter, 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 ammeter, ammeter, voltmeter, voltmeter. Okay, 4 cells, 1.5 volts each. So here I am considering 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. Here is the ammeter, voltmeter. Here is a switch. What is switch? What is the type of switch? Closed switch. What is the type of switch? Closed switch. What is the type of switch? Closed switch. So nichrome wire. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. Iron metals. Nichrome wire is an alloy of nickel, chromium, manganese, and iron metals. So switch, open, closed. Ammeter, voltmeter, and the fifth one is connecting wires. Connecting wires, connecting wires, connecting wires, connecting wires, connecting wires, connecting wires. Yes, so these are the materials required. Materials required. Materials required. Materials required. Materials required. Materials required for doing Ohm's law. For doing Ohm's law of activity of Ohm's law. For doing activity of Ohm's law. For doing activities of Ohm's law, what are the materials are required? 4 cells, 1.5 volts each. 4 cells, 1.5 volts each. Nichrome wire, nichrome wire. It is a resistor here. It is a resistor in the Ohm's law. It is a resistor. It is an alloy of. It is an alloy of. It is an alloy of nickel, chromium, manganese, and iron metals. Nichrome, chromium, manganese, and iron metals. Yes. It is an chrome wire. Yes. And ammeter, voltmeter, switch, connecting wires. Okay. So after understanding the materials required, we will go for the process, the procedure, the procedure. So, what is the procedure? What is the process? What is the process? Process is process is when you are connect. So, if you connect one cell, if you so one cell if you connect, so I'm connecting one cell, I'm connecting one cell, I'm connecting one cell, I am 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 connecting one cell first. First step is step one. You must connect to one cell. After that, you have to note down the reading of ammeter and voltmeter. You should note down. You have to note down. You must note down. You have to observe. After that, you have to note down the values of ammeter and voltmeter. Ammeter and voltmeter. Ammeter and voltmeter. 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 After that, you have to mention in the tabular form. You have to mention in the tabular form. So 1, 2, 3, and 4. So why you are considering this many lines? What are those represents? I am considering here serial number first. Next, serial number first. Next, number of cells. Number of cells. Number of cells. After that, serial number, number of cells. Serial number, number of cells. Serial number, number of cells. After that, ammeter reading, voltmeter reading, V by I form, that is equal to R. So Ohm's law gives the definition of Ohm's law gives the definition of Ohm's law gives the definition of resistance. 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 So now after connecting one cell, so one cell after connecting one cell, after connecting one cell, after connecting one cell, note down the reading of ammeter and voltmeter. After connecting two cells, after connecting two cells, note down reading of ammeter and voltmeter. First you have to connect one cell and note down the reading of ammeter and voltmeter. Next you connect two cells, again note down the reading of ammeter and voltmeter. So and the same process repeat for 3 and 4. The same process repeat for 3 and 4. Same process repeat for 3 and 4. What is that process? Connect the cell, current will pass, ammeter reading you measure, voltmeter reading you measure, and you mention in the tabular form given below. So where is the tabular form? Here it is there. What are the points contained in the tabular form? What are the points? First one is serial number, second one is number of cells, third one is ammeter reading, that is nothing but current, then voltmeter reading, that is nothing but potential difference, and V by I, that is nothing but resistance. V by I is nothing but resistance. V by I is nothing but resistance. Resistance, 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 resistance. So what is the resistance definition? The phenomenon of opposing the electric current in the circuit is called resistance. The phenomenon of opposing the electric current in the circuit is called resistance, 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 resistance. The phenomenon of opposing the electric current in the circuit is called resistance. SI unit of resistance is ohm. SI unit of resistance, ohm. Yes. Now it gives that Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Okay, so this is the process, this is the procedure. So this is the this is circuit diagram, this is the tabular form, and this is the process, and this is the this is Ohm's law. Myself Shiva sir. So my channel name is Student Brand. So now you can see, oh my God. So if you draw the VI graph, 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 VI graph. If you draw the VI graph, VI graph, VI graph, graph of VI, VI graph, graph of VI, VI graph. So graph is drawn. Okay, so graph is drawn. Okay, with the help of V and I. So V on x-axis, I on V on y-axis. This is y-axis. I on x-axis. V on y-axis. I on x-axis. Current is on x-axis. Potential difference on y-axis. Here. Again 2 points are there. Again 2 points. Again 2 points are there. What are those? Ohmic conductors. Ohmic conductors. Remember ohmic conductors. Ohmic conductors. Ohmic conductors. Ohmic conductors. Ohmic conductors. Next one, non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors. Non-ohmic conductors, non-ohmic conductors, non-ohmic conductors, conductors. What are the ohmic conductors? The substances which obey Ohm's law. The substances which obey Ohm's law are called ohmic conductors. The substances which obey Ohm's law are called ohmic conductors. The substances which does not obey Ohm's law, the substances which does not obey Ohm's law are called non-ohmic conductors. Non-ohmic conductors. Keep this in mind. Very, very important, these 2 points. Ohmic conductors and non-ohmic conductors. Ohmic conductors graph is linear. Ohmic conductors graph is linear. Ohmic conductors graph is linear. Ohmic conductor graph is linear. What about non-ohmic conductors? Non-ohmic conductor graph is curve. Non-ohmic conductors graph is curve. So here is about ohmic conductors and non-ohmic conductors. So next one, resistance. I said no. Resistance. I said no. Resistance is the phenomena of opposing electric current. Resistance is the phenomena of opposing electric current. Resistance is nothing but phenomena of opposing the electric current. Phenomena of opposing the electric current is called resistance. SI unit of resistance is ohm. Resistance depends on length, area of cross section. Resistance depends on length of the conductor, area of the cross section. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. So R is directly proportional to L. R is inversely proportional to area. R is inversely proportional to area. So R equal to rho into L by A. R equal to rho into L by A. Rho equal to, what is the rho? Rho equal to RA by L. Rho equal to RA by L. Rho equal to RA by L. SI unit of resistance is ohm. And SI unit of area is meter square. SI unit of length is meter. SI unit of resistance is ohm. SI unit of area is meter square. Meter square, meter square, meter square. So meter get cancelled. Oh my god. Meter get cancelled. Remaining is ohm meter. Remaining is ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Ohm meter. SI unit of resistance is ohm. SI unit of resistance is ohm. So, is this two are same? Resistance and resistivity both are same? Resistance, resistivity both are same? Both are same? No, resistance and resistivity both are not same. Resistance is the phenomena of opposing the electric current. Resistivity is the property of the material. 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 Resistance is the phenomena of opposing the electric current. Phenomena of opposing the electric current. Resistivity is equal to resistance of a conductor per unit length and unit cross sectional area. So the definition from here itself you can get it. Resistivity is equal to resistance of a conductor per unit length and unit cross sectional area. Resistivity, 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 resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. Unit cross sectional area R equal to rho into rho equal to RA by L. Resistivity is equal to resistance of the conductor per unit length and unit cross sectional area. Yes. So SI unit of resistivity is ohm meter. 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 SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. Ohm meter. Ohm meter. Yes. Come on, we'll discuss the difference between resistance and resistivity. Come on, we will discuss the difference between resistance and resistivity. We will discuss difference between resistance and resistivity. I am talking about resistance now. I am going to talk about resistivity. 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 Resistance. Resistance is the phenomena of opposing the electric current. Resistance is the phenomena of opposing the electric current to R equal to rho into L by A. R equal to rho into L by A. Formula of resistance. Formula of resistivity. Formula of resistivity. Rho equal to RA by L. 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 So second one is So second one is SI unit of resistance is ohm. SI unit of resistance is ohm. SI unit of resistance is ohm. Symbol. SI unit of resistivity is ohm meter. 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 SI unit of resistivity is ohm meter. Resistance depends on resistance depends on resistance depends on resistance depends on length of the conductor, area of the cross section. Resistivities does not depend on Resistivities does not depend on physical dimensions. Resistivity does not depend physical dimensions. It does not depend on physical dimensions. It does not depend on physical dimensions. So depends not does not depends on does not does not depend does not depend does not depend. Fourth one, it depends on temperature. 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 Temperature. And it depends on material. It depends on material. Material, material, material. It depends on material of the conductor. It depends on material of the conductor. It depends on material of the conductor. Keep these points in mind. Keep these points in mind. Resistance, resistivity R equal to rho into L by A. Rho equal to RA by L. SI unit of resistance is ohm. SI unit of resistance is ohm meter. Yes, resistance depends on length and area. On physical dimensions, resistivity does not depend. Resistivity does not depend on length and area. Length and area. So resistance depends on temperature. Resistivity also depends on temperature. So resistance depends on material. Resistivity depends on also the material of the conductor. Yes. So this is about resistance and resistivity differences. So if you have any doubts related to this topic, so you can comment. If you like this video, please do like, share, and subscribe to Student in the Brand. This is your sir. So my channel is Student in the Brand. So thank you so much for joining and listening my class.